Welcome you all to this video lecture. Here, this is the continuation regarding to the topic accessing IO device. So, in this previous IO device, we have discussed regarding to the control registers and data registers and keyboard registers and interfaces with respect to the keyboard. And now we are discussing regarding to the display registers or display interfaces. So, continuity to that, we are get starting over here with the display out flag. So here with respect to that, if we have mentioned when the display D out is equal to 1, so there is it tells us that the display is ready, whereas the D out is equal to 0, the display is busy. So it states us that with respect to here over this D out flag, the processor monitors what the D out, and it will senses the ASCII encoded characters only when the D out is 1. So sending the character clears us what means the DOUT to 0 until the display becomes ready again. So the next thing we are going to discuss over here is the programmed controlled display output. So here this program controlled display output says us what means. So the right wait. So the right wait says us what the check the display output, whether the display output is equal to 0, it will go for the S option. So S option means what, it will keep checking till the display output will get 1. So no, when we receive the display output is equal to has some value 1 means it senses the character, so it automatically displays the data. So with respect to that read out, with respect to this read out the data out flag, so it will automatically branches to the top right wait if d out is equal to 0 and transfers r5 to display data. So automatically the register r5 we need to display that is a display data output. So the r5 has some data values, so that will store display in the data output. So the next thing which we need to clearly have idea over with respect to this instruction store byte r5 comma display data. Here this r5 represents some hexadecimal value. Let for an example, previously we have mentioned the r5 as equal to 41h, that hexadecimal r5 is equal to 41h. So with respect to that, it is represent the what ASCII value as a. So automatically then it stores us byte the r5 comma display data, which will cause us what means the things is. So first the thing which it is go where means, so r5 register 5 it will go, so it displays us the display data register r5 it will go, it will display the data dd, which is display data. So the next is display. So the next is what it display means, that ASCII value, ASCII character 41h value representation a. So these things has been get completed. So now we need to have a clear example with respect to the keyboard memory and display. So suppose if we are the user, we are going to get a press over to a character such as a k, or else I take this previous example as a character a. So first thing here, the keyboard generates a character. So that character a, if I press a means it automatically go to, so it automatically will go to the, if example a I pressed, so this a will go for the ASCII. So here that ASCII has some representation 41h. So the next step is the keyboard stores us it. So here this with respect to the keyboard data, which we discussed in the previous video, keyboard data, it stores us this 41h. So then automatically the keyboard interfaces kin will display 1. So the next is the processor detects that kin means it will loads the this instruction load byte r4 comma display status and r4 comma r4 hash some values. Here I have mentioned this as a 2 as a value. So the next thing is that the load uh, again the processor need to read that character. So again I am giving the what means instruction called as a load byte r5 comma keyboard data. So therefore this keyboard data, which means that the register r5 has, so automatically the register r5 has what 41h, that character ASCII characters. So here After that, the process stores it in a memory. So any memory addresses which we have can be placed. So after that, the process checks for the display. So d out. So if uh, d d out is equal to 1, it will stores what? It will stores us the byte or file and display the data. So the final thing is that display shows us what? A. So the keyboard and a monitors us under memory, which means that a keyboard, memory, and display combination has these steps such as keyboard generates a character, keyboard stores this. Next, the kin becomes as value as a one indications. So after that, the processor detects the kin. So after that, the processor reads those characters. So the followingly, the processor stores in a memory. After that, the processor checks the display, the process sends the characters, and finally it showcases the display things. So next we need have upcoming topics regarding to the of interrupts. So here we discussed regarding to the of in both videos program control IO interrupt sorry IO based IO. These are the things as we have discussed. So the thing finally we need to keep a thing as a reminder means the processor, so it will get interconnected with the IO bus interface. So in that IO bus interface get splitted over to the keyboard and display. The keyboard has the keyboard data, keyboard status, and keyboard control, whereas display has its display data, display status, and display control. So keyboard will all get relayed with the kin status, kin flag. So display will all get relayed with that of a D out. So kin available means kin is equal to 1 means the character available. D out is equal to 1 means what? It's ready for the data. So the core idea, the core things is which we need to get remind finally is the processor communicate with the IO device with the help of what? The interface registers. So automatically it will check the status before transferring the data. Since because the processor and IO devices are operated at different spaces. Thank you.